See
Okay,
you,
good
Mr.
morning.
Gideon. Hello, everyone.
Dr. Comfort, I know that your voice is unique. You are here. Good morning. Okay, Chris, are you here? Okay, Christopher, I can see your name. You are here. Nice to meet us today again. I welcome each and every one of us in my group, the IAMESEP, on this another episode of our webinar series. Usually hold the last Wednesday of every month. Today is another day. We are going to be looking at some issues that surround the testing, and I think this is the second time we are treating the issues of testing on this platform. So today we'll be dealing on an important topic again that has to do with at least comparative analysis of different techniques of testing in this industry. Once again, I welcome you all. As the tradition demands, I will just give us a benefit of those that are actually joining us for the first time. This is actually being brought to you by IAMESEP and also IMAG. IMAG is a group that is in charge of advocacy within IAMESEP. IAMESEP is Initiative Advancement in Mining, Earth Sciences, and Environmental Protection. We are non-governmental. We're composed of different professionals, geoscientists, mining engineers, entrepreneurs, lawyers, businessmen that actually have interest in mining in Nigeria. I will also bring you information concerning mineral resources of this country. And also we want to foster awareness concerning geology, the environment, and the sustainability of mining based in Nigeria. We also provide hands-on mineral resources programs, innovative educations, and practical mining training opportunities and mentorship to enhance sustainable development of extractive industry. This is who we are. Today our president and founder of this platform, Dr. Mrs. Salau, is on a workshop in Dakar, Senegal, and they are working on the back. I think with time, we'll also be enjoying the same platform that the DOC and the Canadians are actually enjoying in terms of reporting resources as Pan-African code. That is back. I think that's actually what they're actually working on now, and she might not also be joining us here because of some of the network issues with that. Okay, that is it. Today we will run about, as usual, 40 minutes presentation by one of our own. Yume is one of us and been very been contributing for a very long time on this platform. Is well experienced. Will allow him to do justice to today's discussion, and after that, contributions will also follow from various other professionals. And after the contributions, some questions definitely will come up, and we'll have to treat that. That is, give about 40 minutes to that, and contributions 15 minutes, questions about 15 minutes. I'll bring this to an end for the day. So that is how we're going to run. I don't know, AQ, are you here? You are here. AQ, let me see. I can't see your name here.
Yeah, good morning. Good afternoon. Yes, good afternoon, everyone.
Okay. Okay. Good afternoon. Please, AQ, if you are here, can you just also make it just an opening and welcoming remark?
Thank you very much.
The other person. Yeah.
Right. Once again, good afternoon, everyone. Because I would like to crave your indulgence because of the bandwidth I would like to put off my video, but I can still speak.
No problem.
Would you mind?
No problem.
All right, thank you. Yeah, so good afternoon, everyone. You're welcome to this webinar. And like IMAG always does, you know, we always try to do the best, the best to all topics that come up. And it is my pleasure that Mr. Chris, who is the presenter today, is someone that is well versed in this area, this aspect of the industry. He's someone I've worked closely with, and is someone that I have learned a lot from. So yes, the comparative analysis of modern mineral testing techniques in Nigeria's mining sector is a very pertinent topic, in the sense that this is mineral testing, or assay, as we put it, is what really gives us the confidence, or brings the knowledge of the type of grade, quality, or even the let's say the truth about what is obtainable in any environment. So, and you know, of course, I won't delve into the technical aspect, but I know there are several advantages to this, because it is meant to be some sort of enhancement of skills for geologists and mining engineers, and even laboratory technicians that might be attending this webinar. Then, of course, it gives us the practical knowledge on how to improve on mineral testing, the accuracy and efficiencies. And then, of course, I know Mr. Chris will delve into the investment and operational aspects. And one thing that we should not even forget is the enhanced safety and environmental management. So with this, I think I welcome everybody, and I wish us productive deliberation ahead. Thank
you. Okay. Thank you, AQ. Thank you for that wonderful opening remark. I think I will go straight away to just make a brief introduction of who our guest speaker is. Chris has been an experienced metal and mining and professional with some demonstrated history of over 10 years experience in this industry. Also in the metal laboratory industry, mineral beneficiation and mineral concentration plants. He specializes in exploration, exploitation, and extraction of different minerals, critical minerals, base minerals, industrial deposits, rare earths, metals, and technical evaluation of mineral resources and reserves at different stages of mine. He's also a skilled person in mine planning and development, and also is well known for analytical instruments proficiency, which involve the XRF, the WXRF, the XRD, the AAS, the ICP OES, the ICP MS, GC, TCD, FP Analyzer, SEM, ED, XRF. So I think these are some of the practical skills I've known him with, and I've worked with him in different fields and in different projects, and I've also visited some of his projects. Chris Uyeme is one of us, and with this, I will want to make a welcome of Chris to this platform as you take over. I'll be sharing from here, or you share from your end?
No, please share from your end. It's fine. Thank you.
Okay, no problem.
Good afternoon, everyone. I'm so happy to be here once again, and I want to take this opportunity to thank every members of this platform. You know, we're already going global, and the contribution of this platform is something we cannot joke about. I've seen it in international levels and everything, and you know, so thank you very much for the organizers, the coordinators, and every other person that is making this project forthcoming. We appreciate you. In fact, Nigeria is appreciating you in general, because whatever we are doing here, we're also adding value to our country, Nigeria. So thank you. Thank you, Mr. Gideon. Thank you for everybody. I can also see some big names here. Thank you very much. So let's dive directly to the topic. So today we'll be looking at comparative analysis of in Nigeria mining sector. Next slide for me. Next slide. So basically what I will be doing today, I don't want to go far. It's a very broad topic. It's a very broad topic, so I don't want to go in much length. So I'll just be pointing some salient points that are important for us when it comes to mining and what we should watch out for as miners, as practitioners. And I'm not going to do it in such a way that it's only people who are in the mining sector that will understand it. I'm going to make it in such a way that is generalized. Whether you are in a legal profession, you are into marketing, whatever you are, should be able to appreciate the value of today's webinar, because when it comes to testing, it's everything. Definitely, we know that Nigeria is definitely blessed with a lot of minerals resources, which everybody is aware. Currently, by our own statistics, we have over 40 valuable minerals deposit putting across critical and industrial minerals in Nigeria, like lithium, beryllium, tantalite, monazite. You can name it. Even as we speak, there are some states in Nigeria that we're not even thinking that this mineral exists, but by virtue of exploration, on virtue of testing, we are able to come up with a value that, oh, so this mineral can actually exist in these locations. Places like Cross River, nobody ever thought that there's going to be lithium in Cross River, but as I'm talking to you right away, people are actually getting thousands of tons of lithium from Cross River. So Nigeria is blessed. In each state in Nigeria, there's this unique character, or there's this unique mineral in each state of the federation. So if you count all the 36 states we have, including the Abuja, which is a very federal capital territory, there are minerals. So minerals in Nigeria is definitely very blessed when it comes to minerals. And also, despite the fact that we have a lot of minerals, we are in deal with these minerals, the productivity level in this sector is very, very sufficient. Already we know the causes, like, insecurity is also one of them. Attracting the investors into this industry is also another different thing, because most of the investors sees Nigeria or sees Africans as fraudsters and everything. So there's a lot of issues in the mining industry, but notwithstanding, as a Nigerian or as Nigeria, we are definitely going to be making way. We are definitely going to be going forward until we get to a system where we'll get to a point where we standardize, and then we'll be known in the world as the leading mineral exporting country. Next slide, thank you. Next slide. Next slide. So these are just pictures of available minerals, just a photo gallery that I've put up together for the available minerals in Nigeria, ranging from copper, lead, lithium, zinc, any mineral you can think about, you can find it in Nigeria, including the monazite, the rare earth that China is already fighting. We have it in Nigeria. Everything, industrial minerals, critical minerals, they are all available in Nigeria in different geopolitical zones. Next slide. Right. So the base of the topic, mineral testing, is very, very important, because when talking about mineral testing, we are trying to look at the quality and the quantity of your ore. So just getting an ore is not enough. You need to know the quality of your ore. You also need to know the quantity of your ore, and that is what mineral testing has to definitely give you the concentration and the grade of this element or compounds in your ore, and also tell you the relative abundance or amount of this element in your ore. So mineral testing is very, very important, and it cuts across every sector of the mining industry. Please, next slide. Next slide. Yeah, it cut across every sector of the mining industry. So we can't, please go back. Go back to the previous importance of mineral testing. Importance of mineral testing. Yeah. So mining industry requires quality control and then reliable testing and analysis at each critical stage of the process. Whether you are into exploration, you definitely need mineral testing, because After spending so much thousands or millions of naira or dollars for your exploration, you still have to fall back to testing. So knowing the right testing technique and knowing the right testing practice will help you a lot for you to make an informed decision. And that also goes to same thing as mining. Even during your mining as well, you also have to know your cut-off grade at each point in time. So you cannot just generalize that, oh, I'm at 20 meters. At 20 meters, the grade of my mineral is 3%. You know, it can't be like that. Your ore is not uniformly distributed in the host rock. So definitely as you are going down at a depth or as a or in depth or whatever, there will be change in mineralogy, there will be change in geochemistry, and it's only the mineral test that can definitely give you an information of what you need to do per time so that you can actually, work on economic value. Then also for processing again, mineral testing is very important when it comes to processing. Like if you want to set up a processing plant now, the first thing you do is for you to do a metallurgical testing, because the metallurgical testing is going to guide you to know the gang minerals that you need to separate, the minerals that are not important to you, how you can optimize your processing plant and everything. So in every part of the mining sector, mineral testing is important. In exploration, as you are going to the field to do your reconnaissance, do your mapping, do your either your geophysics or your core drilling, everything boils down to your final decision boils down to the lab or boils down to the mineral testing. And then when it comes to mining, the same thing. While mining and during your mining, you are also testing what has been mined, what has been blasted. You have to know the feed grade of what has been blasted, and then maybe you are doing sorting as well after blasting. You also need to know the grade of your minerals. And for you to know the grade of your minerals, you also need to do mineral testing. And then for processing as well, for you to know the right equipment that you can use, the right mineral processing equipment that you can use to extract your minerals from the ore. You also need to do a metallurgical testing, which all boils down to testing. So it's very interesting topic because it cuts across every sector of the economy. Every decision that has to be made in this mining industry has to come from the grade point of, it has to come from the point of grade. What is the quality of your mineral? What do you have? But even if you're going to get investor now, if you present your budget to your investors or you present your business plan to your investor, after your investor might have asked you of your reserve, the next thing he's going to have to ask you is what is the cut-off grade? What is the grade of your mineral? So without mineral testing, you cannot be able to answer those questions. Even if you answer those questions, what confidence you have in answering those questions? What kind of analytical technique did you use to be able to come up with your grade? Is that analytical technique sufficient enough to give you information about that ore body? Is that analytical technique sufficient enough to be able to give you confidence when you are presenting this paper or you are presenting your report in international level? So mineral testing is very important. Thank you. Next slide. So you see a young man on the field doing exploration. At the end of the day, whatever sample he's going to take here, whether it's a mapping sample or reconnaissance samples, he's still going to go back to mineral testing. Next. So you can see a mining site heavily mining. The decision of this mining process stems from mineral testing. So even after your exploration, you have gotten your exploration data, you have modeled your reserve and everything, your decision still boils back to the grade that you have gotten from your exploration. Is this grade economically viable? If I mine this grade, if the grade is 5%, if I mine this grade, can I get economic value out of this grade? So even the mining too is dependent on mineral testing. Next. Then the same thing, a processing plant as well. Before you can even set up any processing plant, the first thing you need to do is your metallurgical test work, because the metallurgical test will definitely tell you what are the constituents of your mineral, the geochemistry of your minerals, and how you can efficiently extract them. So even setting up a multi-million-dollar equipment or a processing plant like this without mineral testing, without knowing the grade, without knowing the geochemistry and the mineralogy of your ore, you can't do anything. So it's very, very important. So you cut across every field of the mining industry. Next. So historical testing techniques. Over time, testing is as old as man, as we all know. Like things like gold, silver has been used in ancient time, like 3,000 years ago. For them to actually get this gold material, they adopted a very simple technique, and that technique was just fire assay. And what was fire assay about? They take either the gold was an alluvial, they put it inside a very hot furnace or a fire that has a very high temperature, extract the gold out of it. Or if it was in a rock form, they also take the rock and then they put inside a fire that has high temperature and then they melt out the gold. So testing is as old as man, and even the Egyptians can also have it that they have been testing their material, but those a group that cannot give you more information about your mineral of interest. So there are other traditional and we still refer them to traditional, method of analysis. Because one thing about testing is, as we are testing, we are looking for the best approach or the best method we can use to get the grade or to get the quality of our analyte, paying attention to the environment, because the environment is another thing. So if during the process of your testing, you're going to pollute the environment or you're going to make the environment unsafe, that method cannot stand the test of time. So as time goes on, as ages passes, the method is going to be developed, optimized until a system where a step where we have a system that does not pose any health challenge to the environment that we can adopt. So these are the three traditional methods of analysis. We can go to next slide. Let's briefly talk about tachymetry. Yes, of course. So those of us that have been science students, even art students in secondary school, you definitely see this, where you have a conical flask and then you have a burette and then a Richter stand. This is also a traditional method of analysis, and it's very useful today. In fact, most Chinese prefer tachymetry when it comes to minerals that can form complex minerals like copper or lead or zinc, or they always prefer tachymetry analysis. Because in tachymetry analysis is simple. You are using a known concentration of a standard that can form a complex with the unknown concentration of the element you are looking for. So take for instance, now maybe you are looking for lead in a sample. After converting your lead to a solution, maybe through acid digestion or by fission, then you don't know the concentration of the lead in the sample, but you know a standard that has a known concentration, which can actually form a complex with the lead in solution. So you can maybe, let's say, complexometric titration, where you can use your EDTA or any other chelating agent to chelate with your unknown concentration of the lead in the solution. And then at the end of the day, you are able to come up with the fact that, oh, this is actually lead, this is the concentration of lead. And sometimes indicator can be used to know the endpoint or the equivalent point, or sometimes it can be a potentiometric titration where you are going to put some a probe like electrode inside, and then you record either you record the pH or the conductance of the solution. Once you get to the endpoint where maybe there's no sharp change in the color, or there's no sharp change in the conductance or the pH of the solution, then you can now use that to extrapolate to know the concentration of your lead or zinc or any other element that can form complex in solution. Next slide. So there's another traditional method of analysis called gravimetry. It's also still in use today. When we say traditional, we are not saying that it's olden days that is no longer in use. Even the tachymetry, we use it every day on a daily basis. So the gravimetry as well is also being used even till today. So like gravimetry, just like the word implies, we're talking about weight measurement. So you have a sample, and then you want to know the elemental composition of the sample, and you need to look for a way to precipitate that sample and then make it to become a residue, so that at the end of the day, you can weigh the residue, and then from the residue, you can now extrapolate the concentration or the grade of that particular element in the sample. Take, for instance, now if you want to check silver, to those of us that love checking silver through gravimetric, certainly, if you have a sample of silver, let's say silver chloride, maybe you turn it to silver chloride, maybe during your digestion, and then you react it with HNO3, definitely a precipitate is going to be formed. When I say precipitate, I mean insoluble. It becomes the silver content in the solution becomes insoluble, and then you can now filter off. When you filter, you can burn off the filter paper, maybe use a muffle furnace at maybe 500 degrees or even 700 degrees centigrade. Whatever is left after ignition, you can weigh back, and then from the weight difference, after weighing from the weight difference, you can determine the concentration of that particular element of interest in your sample. Next. And of course, colorimetry, just like the name implies, color. This is a very simple technique, even still used even as of today, although it has been optimized with the addition of instruments like UV visible spectrophotometer. So for colorimetry, you have a compound or you have an ore, you turn the ore into solution, and then you look for chromophore or chromogenes that you can use to develop a color on that particular ore of interest. So take for instance now for iron, you can develop color with an iron in such a way that it can give you a yellow complex or a yellow color. From that yellow color, you can know the absorbance of the absorbance or the intensity of the yellow color, and from there you can also extrapolate the concentration of the iron or the concentration of any other elements in the ore that can actually form color with the addition of chromophores. Next slide. Then what are the challenges of the classical method or the traditional method of analysis? Of course, there are a lot of challenges. One of them are simple. Let's start with the advantage. Even before going to challenges, look at the advantage. It's simple and inexpensive. When it comes to those methods I told you, it's very simple and inexpensive. When I studied chemistry, I had what is called a burette, a conical flask, and a stand in my house. Even as of then, I was able to afford it because it was very simple. So when people were going to their classes for titration in the lab, me, I was really doing my titration at home, knowing the endpoint even before coming to the lab, even before coming to the school, and then publishing the result to them. So it's very simple and very inexpensive, and then requires minimal equipment. From what I've mentioned, they don't need much equipment for titration. Your burette, your Brito stand is enough for you to carry out your titration. Then with your standard, the concentration of known solution, your standard is enough for you to carry out your analysis. Then the same thing for gravimetry. For gravimetry, you just need a scale, a balance, maybe an analytical balance and possibly an open top balance. And then you need a furnace. That is all. You are done with your analysis. And then you need some precipitants, compounds that can be used to precipitate the elements in solution. And then also it's stable for routine analysis, of course. Then for the challenges, they are less accurate and precise. We didn't say they're not accurate. They are very, very, very accurate, but it's less accurate in the sense that it's prone to human error. In every phase of this process, human being is involved. Human is involved in the process of preparing your chemicals, in the process of titrating and everything. There is always prone to error, prone to human error, and it's less accurate and precise because of the too much interference of human activities or the, let me say, chemists in the process of doing the analysis. Also, it's limited sensitivity and selectivity. Of course, like what I made mention during titrimetry, when you are titrating lead, you can't titrate lead and zinc in the same solution again, except you are masking. So if you are doing an analysis of one element at a time, you can't test two. So if you have a lead ore that contains both lead and zinc, you have to first of all know the concentration of lead. You mask the solution, and then you mark the solution, and then after knowing the concentration of lead, you unmask it again, and then you now titrate the zinc. So you can't titrate the zinc and the lead at the same time because it lacks sensitivity and it also lacks very poor selectivity. And also, it definitely is time consuming because you have to prepare the whole of this reagent, prepare all of the chemicals and everything. Then high chemical consumption, of course, all the processes I've mentioned, they use chemicals. And then also environmental concern also important. But at the end of the day, after titrating, imagine maybe you are doing acid-base titration. After titrating, you have to dispose the acid and the base. And you might not know the right approach for you to do that. Maybe you have to neutralize the acid and the base so that you don't pose any threat to the environment. But even if you neutralize that, a neutralization reaction will give you salt and water. And if you throw away the salt and water, definitely it will cause imbalance to the ecosystem, or imbalance to the salt pH, or imbalance to the salt alkalinity. So it's very important that you understand that it's not environmentally friendly, and it causes environmental concern. Next. Now, overview of mineral testing techniques. Now, we're talking about modern testing techniques. It's the same thing as saying instrumentation, because that is it. It's the same thing as saying instrumentation. But you also have to know that these modern mineral testing techniques cannot survive alone. There are a few of them that can just be non-destructive, they can just be on their own. But there are others that are still dependent on the traditional method of analysis. Take, for instance, weight analysis. Like when you are sending your samples to the lab, I always overhear people saying, are you doing weight analysis? I want to do weight analysis. Of course, even that weight analysis you are calling, it still falls back to traditional method of analysis. But at the end of the day, you still use instrumentation. So the modern method of analysis still lies on the principles of the traditional method of analysis. And here I've listed some modern or instrumentational method of analysis that is used in Nigeria and also in the world at large. And I'm very specific because I don't want to mention some instruments here that have no use to us because of the time. So I just mentioned XRD, LIBS, ICP, OES or AES, AAS, IPMA, Queenstown, MLA, and then Portable XRF. These are the modern mineral testing technique. There are a lot of them. There are a lot of them that are available, but these are the ones that are of interest to us, that if you subject your sample to any of these methods, there are some important information you can derive from your sample. Next slide. All right, so that takes us to XRD. Of course, when it comes to mineral testing, the first question you need to understand, or the first question you need to ask yourself is, what are my analytes of interest? What am I trying to achieve when it comes to the mineral testing? And that is one of the issues that we are having when it comes to Nigerian mineral testing, or in the Nigerian mining sector. Someone will send, I'm talking from experience now, someone will send a sample to the lab and tell you, test the sample. Some will not even tell you that, oh, what we're actually looking for, maybe lithium, or we're actually looking for lead. They will not even tell you, and they will not tell you to just run the analysis. It shouldn't be like that. So once you send a sample to the lab, you as the geologist, or you as the person bringing the sample, should be able to know what you are trying to discover. You should not allow the analyst to discover it for you, because there are pros and cons there. If you allow the analyst to discover what is in your sample for you, there will be error. Now, when I say error, it means if you bring a sample to me and tell me that, oh, I need lithium, all my focus will be on lithium. And if there's any other element that may cause the lithium signal to not come out very well, or that may cause attenuation, let me use that word, attenuation, then I have to mask it in such a way that I'm paying much attention to lithium, so that whatever result I'm getting, I'm confident about that. So XRD is also a very important, very wonderful instrument that is used in mineral testing, and it's a non-destructive analytical technique. And when I say non-destructive, you can't destroy the sample. So if you bring in your rock sample, the highest I can do for the rock sample is just for me to turn it into powder to be able to be assayed by the XRD. So it's non-destructive. It doesn't use chemicals. You don't need to use chemicals. And it's very good to characterize the structure of crystalline materials, and also to determine mineralogy. So take, for instance, we bring a sample to me now. You want to know the minerals that are present. We are not talking about the elements now. Please take note of that. In XRD, we are not talking about elements. XRD is not for elemental analysis. XRD is good for mineralogical analysis. You know the kind of minerals that are present in your sample. So if you bring a sample to me and I subject it to XRD, what I am expected to see in my XRD are the minerals, right? Are the minerals. So I'm not expecting to say something like silicon oxide. That is wrong. What I'm expecting to see, if it's a quartz sample, should be quartz. Maybe I'll give its own characteristics, wavelength, Y coming down, so you can know that, oh, this is sodium. And if it's lithium, and the best part of this LIPS device is that I can also test lithium for you. In situ. You don't need to take your lithium sample to the lab. I've lost my screen again, sir. So you don't need to take your lithium sample to the lab. On the field, you can definitely shoot your lithium sample, and then you can get the concentration of your lithium sample. So this is how it looks like. There are different series. This is the latest series from SciAps, Z903, and it costs about, I think, $68,000 as of today. Yes, $8,000 as of today. So this is how it works. There's a laser here, produce a plasma, and then you shoot your sample, and then there's an excitation. And once they're coming back to the ground state, they emit a radiation, and that radiation or that wavelength will be picked up by the detector, and the detector will be able to interpret for you the kind of element that are present. And it's used for multi-element analysis. Please, next slide. Next. Next. Good. So interesting features is the LIPS is sensitive to all elements. This is my hand there. I was in the field trying to run some analysis on some samples that came across to me. So it's sensitive to all elements, just like I said, with detection limit of around 0.1 to 200 ppm. So it means you can have 0.1 ppm as your detection limit. Please go back to my LIPS as your detection limit, depending on the sample. Then it needs little or no sample preparation. Just like I said, you can take it to the field, carry your rock, and you shoot your rock directly. It will give you the geochemistry of the rock. So you don't need to take the sample to the lab to prepare. But for you to get more accurate result, then you have to prepare your samples. And one of the disadvantages is that it does not shoot a powder sample. You don't use a LIPS device to shoot a powder sample unlike XRM. So if you have a powder sample and you want to shoot it with your LIPS device, you need to turn it to a pellet. So there are pelletizing machine that can compress the sample. So when I say pellet, you turn it into a tablet that is hard. So that is the only way you can shoot, and that will give you a more robust full result. So you can use this device on the field to make urgent decision. But note, the LIPS device cannot be used for grade control. I've seen a lot of people, including the Chinese, taking this device to the bush. They will point on a device to a rock and say, oh, this is lithium. This lithium is 5.4%. No, it's not true, because we all know that the ore itself is not uniformly distributed throughout the host rock. So for you to get an accurate result, you have, after shooting your sample in the field, for your field, use it for the purpose of identification. You don't use it for grading. So you are taking it to the field, you can only use it to the field to identify that, oh, this is copper, this is lithium. I've used it for copper a lot of times. This is beryllium. You can also detect beryllium for you. You can look from the screen, you can see beryllium concentration there. You also detect beryllium for you, and any other element as depending on what the constraint of your sample. So don't use it for grade control. If you want to use it for grade control, they have to take it to the lab, vaporize it, turn it to powder, turn it to pellet, and they can actually get an average quality of your a quality grade of your mineral ore, paying attention to your CRM, to your standard. You can't just take your material to your device to the bush and begin to shoot. You have to ensure that the material is calibrated. There are certified reference material that can always trace back to the grade that you're of interest. Then the next one is ICP, inductively coupled plasma. It can either be an MS, depending if you're using an MS detector, or it can be AES. It can also be OES. The AES stand for, the MS stand for mass spectrophotometer, is a detector attached to the ICP unit. And then the AES stands for atomic emission spectrophotometer. So it can be an emission principle, or it can be OES, optical absorption spectrophotometer. So depending on whatever setup it is. So currently now, almost everybody in the world now are dying for ICP because it's very good. I can tell you of a fact, it's very good. For your analysis of rare earth, it can't compete with any other thing. It's very good. And for analysis of any other element, it can give you. Now, what makes it so good is because of the detection limit and the sensitivity. You can use this for, as if you're using MS can give you a detection limit in part per trillion, meaning you want to know the concentration of your sample in part per trillion. Part per trillion means 0.0000001 in trillion, 0 trillions. And it can give you that. And it can also give you in billion, part per billion. It can also give you part per million. It can also give you in percentage. So it depends on what you're actually looking for. And one of the things that most times we make mistakes as geologists is simple. You are taking a sample from exploration. Why are you taking a sample and you're asking the analyst to test the sample for in part per trillion? It doesn't make sense to you. You don't, as a geologist, you don't need result in part per trillion. You don't even need result in part per billion. That will even make sense for you is when your results start from part per million. That actually makes sense for you. If the minerals are in traces, they actually make sense. And then in percentage, of course, it will definitely make a whole sense for you. So when you are sending your exploration sample, understand the limit of detection you want to achieve that will make sense for you. You can't be sending exploration sample and then the lab is reporting the exploration sample for you in percentage. Something is wrong. So because it did not, but it's not the fault of the lab. The reason is this: it did not tell the lab the detection limit you want. So you are sending a sample to the lab, you tell the lab, oh, this is the detection limit I want. I want this analysis to be done in ppm level, meaning I want to capture this analyte of interest at a part per million level. So the lab will be able to know that, oh, I need to do this. And the working principle is definitely going to change. The calibration standards you're going to use definitely going to change compared to if you are doing it in percentage. So it's also very important that you understand the detection limit of the sample you want to analyze so that your result can be competitive anyway in the world. So ICP is very, very robustful equipment. And I just put up a table here, comparison between two of them. I might not have much time to just explain them, but I just want to draw 2 points for you. Detection limit for the MS, the one that has mass spec as a detector, goes as far as 1 to 10 part per trillion. And then the one that has AES goes to 1 to 10 ppm. The current price of it as of today, depending on the MEG, is around $150,000 to $150,000 to $200,000 for the one that have MS. And then the one that is AES goes around $50,000 to I think $70,000 as of today. So you can actually get one. And both of them can do multi-element analysis per time. And unlike AES, where you have to change lamp, this one you don't need a lamp. The plasma is already there. The torch already producing a plasma, which is the source of energy that will cause excitation or absorption depending on the detector you are using. And it's very robust. You can test a lot of elements per time. Next slide. Next slide. Yeah, this is just a picture of a typical MS. This one actually is an MS, not the AES. It has an MS detector attached to it, used for detection of elements in your sample. Next. And also, I also forget to tell you, I remember when I was talking about XRD, I told you that XRD is for mineral analysis, meaning you are knowing the composition, you want to know the mineralogy. But when you want to know the elemental composition of the sample, the LIPS device is going to give you. The LIPS device is not going to tell you that this is quartz. It's not going to do that. The LIPS device is not going to tell you if this is galena. It will not do that. The same thing with the ICP. The ICP can only tell you the elemental composition of your sample. So the choice depends on you. You have a sample you want to test. What are you looking for? If you want to know mineralogy, you should be able to know the kind of equipment that you should go for. Then atomic absorption spectrophotometer, of course, this one is very popular in Nigeria. I think one of my suppliers is also on this call. He's also the one that supplied me all the AS I've been using and I've been installing for people in Nigeria. He works directly with Bob. So anytime you want to look for an AS, you can always reach out to Mr. Abiola. He works directly with Bob. He will definitely point you to the right equipment, the detection limit, and everything. So the AS is very simple. But the only disadvantage here is, it has multiple lamps. You have to change the lamp per element, but it's very sensitive. So if you are testing lead, you have to insert your lead lamp, and then you test your sample. But also remember, this is a combination of both the traditional method of analysis and the modern, because you have to turn your sample into a solution, and it does not test solid samples. Your sample has to be a solution, either properly masked with, if there are any interference that are present, you can mask it for you to increase sensitivity, or you test it with your corresponding standards and certified reference material. So it's a combination of both the traditional method and the modern method of analysis, and it can be used for over analysis of 60 metals. Basically for metal analysis, don't use it for non-metals. So basically for metal analysis, for over 60 elements can be analyzed using the AIS machine. And then we have the EPMA, I call it EPMA, electron probe microanalysis. This is also a very interesting piece of device. Sometimes it has they normally attach, what is it called, a device to it for scanning and then for imaging. So this simply is particularly in mapping the partial distribution of the major and minor element within your ore body. So if you have a sample and then you want to know the distribution of the major element, when I say major element, you are talking about the element that has higher concentration in that particular ore body. Or you want to know the distribution of the minor element, we are talking about the element that has lower concentration in that ore body, then you have to go for EPMA. EPMA will definitely give you that distribution, either in imaging form. You see the way it's being distributed. It will give you different color. This is what is this. This is the element. This element is calcium, and this is the distribution. This other element is this, and this is the distribution. And it's very, very fantastic piece of equipment. I think the cost of it as of today should be around $80,000 or thereabouts. So this is a typical example of a chromatogram developed from an EPMA analysis. You can see the different color corresponds to different elemental composition. And this a detector is a unit is attached to it for the imaging. And we have the image at 20 micrometer. And each of the color corresponds to different elemental composition, and then it's also showing the distribution of the element. The yellow is a different element, the red is a different element, the blue in between is also different. So it shows you the distribution of the major element and the minor element and every other element that are present in your sample. Next. This is also a practical a video, or a picture of how the system looks like. Though this is an outdated version, there are other simple versions. It's not as big as this, very portable. But this one was used in those 1800s by our forefathers. Next. Then we also have automated mineralogy. This is also another interesting aspect of mineral testing. And this has to do with, it does not stay alone. It does not come alone. There's always a unit attached to it. Either a scanning electron microscope is also attached to it, or sometimes ED, energy dispersive wavelength, is also energy dispersive X-ray is also attached to it, and it's very robust. It can be used for the analysis of a lot of minerals, and you can also see the visual distribution of these minerals. And like the one I've seen, the chem scan I've seen consists of 5 customizable measurement modes. So you can measure your bulk. If you want to do your bulk mineralogical analysis, it can definitely do that for you. If you want to do your particle mineralogical analysis, minerals, it will definitely do that for you. And then if you want to do trace mineral and of your body, will definitely do that for you. Next slide. Next. this is also a typical scan where scan electron microscope, we call it SEM or SEM, is also attached for it for imaging and then proper study of your mineral ore. Next. Then, of course, the popular XRF, which I believe everybody on this group, by this time, if you're a miner, you should be able to afford an XRF because it will help you a lot in making good decisions. If you don't have one, then know that you're not a miner yet. And it's not expensive. When they want to buy an XRF, they'll just go and then tell the manufacturer I need an XRF and they will send it down to you. No, it shouldn't be done that way. The right approach of getting an XRF is for you to allow them customize the XRF based on your regional geology. What I mean is that galena sample in Nigeria, despite the fact that it contains lead, is not the same galena sample in Tanzania. Both sample galena contains lead, but there are other deleterious minerals or impurities that are present that might be actually affecting, we call it matrix effect, that may actually affect the X-ray, the secondary X-ray fluorescence from your sample to be captured by the detector. So the best way for you to actually get an XRF is for it to be customized based on regional geology. So if I want to buy XRF in Nigeria, and I want to use it majorly in Nigeria, I need to get samples within Nigeria, send it to the manufacturer. The manufacturer will test that sample, use that sample to cause my X, send it any of whatever I'm measuring, customized measurement that is subject to the mineralogy within my area. So if I'm measuring A in Nigeria, if this same sample goes to China, they should be able to also have the same or similar result as the case may be. So XR is a very robust instrument, very easy to use. You just need to use a non-destructive method of analysis. You just need to prepare the rock. Remember what I told you about the accurate result, because the from the take it to where the sun arises. Rising of history. Actually, of X. So you have it's lead and zinc. Of course, lead and zinc is very simple for you to say. You can use AS for you to test lead and zinc. You can also use another traditional method known as complexometric titration to also test your zinc or your lead. You can also use your XRF as well. XRF is very robust. Once you have a very good certified reference material, you calibrate your XRF with it, you can definitely use to get the concentration of your zinc. So depending on what you are working on, if you are working for exploration, you need to start your concentration in ppm because that is where you can start from. Your exploration, you should not be looking for grade. In exploration, you are not looking for grade. In exploration, you are looking for the present. So the present shouldn't be in percentage, be in ppm. So you can walk around in ppm. So that is also why it's important that when you are sending your sample to the lab, let the lab understand the purpose of the sample. This sample is exploration. So when they are doing the analysis, they should be able to do their detection limit in such a way that if this mineral is present, they can see it even in trace concentration. But if you don't tell them, they will just do it in percentage at the end of the report that, oh, lead is 0%, zinc is 0%. But it's not their fault because they set the detection limit thinking that you want to sell this material, but you did not tell them that it was exploration. Then, of course, for lithium, which is very, 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 very easy, you can use your AAS. You just need to get a lithium lamp to be able to work to determine the concentration of your lithium. You can also use ICP-MS or ICP-OES for you to determine your lithium. But you can't use your XRF. Your XRF cannot be used for the determination of lithium. I've seen a lot of analysis report flying around. Somebody was stating that they use XRF to detect lithium, which is false. You can only use LIPS device to identify lithium. Till now, can still tell people confidently, please don't use LIPS device for grading. The LIPS device can only be used for identification. So it's only LIPS device that I know that is a non-destructive instrument that can be used for analysis of light element like lithium, even including beryllium. But XRF cannot do that. So you can use XRF, but you can use your LIPS device, and then you can also use your you can also use your XRD as well for you to know the mineralogy. Your XRF should be able to tell you that this is spudulite, this is lepidolite, this is petalite, this is amblygonite. Your XRD will be able to give you that. mineralogy formation so they can know the geological formation of the ore. So that is that. And also the detection limit, just like I said, if it's exploration, please keep your detection limit in ppm. It's definitely going to make a lot of sense for you, because at surface level, you are not expected to have lithium of 1% from the top. Just like some of us that will go to the field and then they will take a mapping sample and then they say, this lithium is supposed to be 1%. It can't. The surface sample is already acted upon by a lot of pressure, temperature, wetering activity. So you're not expecting to get anything 1% at the top. So, but if once you take your mapping sample, take it to the lab, let them do the analysis on the trace level for you. Let's see if it's even present. Then you can now go deeper and then continue your research. Of course, tantalite, you can use your AIS for analysis of the tantalite. You can also use it for analysis of your, or you can also use ICP, either the MS or the OAS. You can also use your XRF. Of course, XRF is very, very sensitive to tantalite, very, very 100%. I've used it countless times. I've tested it with SGS in China. The results are almost maybe 0.1%, and they are very good. Okay, so I've already explained the comparative analysis in between the two. Both traditional method and modern. I would not like to go back to this one because it's already what I've been explaining. So you can definitely go back to and maybe from the slide and then get. So regulatory and environmental consideration. Of course, there are regulatory framework in Nigeria that guides Nigerian mineral testing, but which I'm not sure if it's actually working, because my research, I did a recent research last year, that was last year, December, and I noticed that out of 100%, 90% of mineral testing lab in Nigeria are not registered. Yes, 90% of mineral testing lab in Nigeria are not registered, meaning they are not traceable to anybody. They are not traceable to any organization. So they are just doing it because they can test, and so they are not registered. There's no conformity, there's no standard. While out of that 90%, 60% are owned by Chinese. The 60% that is not registered is owned by Chinese. They don't have any paper, they don't have anybody. While the remaining 30% is owned by Nigerians. So the only 10% are the ones that are registered. So there's a regulatory framework that guides the mineral testing as far as mineral testing is concerned, that guide them to ensure that they are actually giving the right result. Because lab result can be misleading. Mineral testing can be misleading. It can make you lose a lot of money. I've seen somebody sending how many trucks, 10 trucks of lithium to China, and the result came out 0%. Why? Because a lab analysis gave him 5.3% as of then, and they thought that was the right analysis. So they go ahead, ship the material, get to China. When he got to China, it was 0%, and he lost money. So lab analysis, so there should be a body regulating this, So some of those bodies are like NINAS, like IPANS of Public Analysis of Nigeria, that they are in charge of regulating the framework of laboratory mineral testing in Nigeria. And what do? From time to time, once you get registered with them, from time to time, they will send you a certified reference material. You test it, or you can do what we call proficiency testing. They bring a sample, give it to different labs, the different labs test together, then they come back again with the result, and then they find out which of the result is closer to the true value. So it's important that there should be a regulatory framework regulating the activities of mineral testing in Nigeria, and also environmental compliance as well. The environmental compliance is also very important. How do you dispose your waste? How do you dispose your waste after using it for analysis? Your acids, your base, your chemicals that are using for the analysis, you have to have a proper waste disposal measure to be put in place for you to dispose your waste, so that you don't end up, causing distortion to the ecosystem. And then lastly, what method to use? This is a very important question that I think is very important that you pay attention to it. I've already explained it on the slide, but just pay attention. As a geologist or as a miner or as an investor, while choosing an appropriate technique for elemental analysis of mineral is not always an easy task, since several parameters which depend on the sample analytical requirement have to be considered. However, in order to limit this discussion, the most commonly used analytical method, I've discussed them above. Many of these instrument techniques also have their own, their own errors. They also have their own deficiencies. But you as a miner or you as a geologist, once you are taking your samples to be assayed or to be tested, you have to know what you are looking for. What is your intended purpose? Not just for you to take the samples to the lab, give it to them, and then you are waiting for your report. No, you have to know your intended purpose and then communicate that intention to the lab so that they know how to follow up. And then also, you need to have a control sample among the samples you are sending to the lab. It's very important. And it's very, very important. When I mean control sample, these are samples that you have tested in other international lab, and then you have known the concentration of this sample. You should be part of your sample when you are sending to the lab. It might not be all, maybe in a monthly basis, you can attach. So take, for instance, you are into lithium exploration. You should have a control sample that contains a known concentration of lithium that should be attached among your exploration samples, so that when the sample are tested and you get the result, you should be able to look at your control sample. If the known value was 5%, is the lab giving you 5% or less? If it's less, then you know that something was wrong or there was a mix-up somewhere. So that control sample will definitely give you confidence that whatever the lab is giving you is actually correct. So if you are into tin, you should be able to get a tin reference material or a tin control sample that you have tested in other places that will give you confidence in your result. So in conclusion, the future of mineral testing in Nigeria mining sector is still like, let me call it, it's still novel. It's still like a baby, and that needs a proper guidelines and a proper regulation. There are a lot of labs in Nigeria. Some are good in one particular minerals or the other, and why some are not good at all. But we're not here to mention any lab. But whatever it is, you have to ensure that you test your mineral right. You understand your grade, you understand the grade of your minerals, the quality of your mineral before you make any economic decision. Your economic decisions should stem from the platform of you knowing your grade of mineral. I think I've done justice to this topic. Thank you very much. Any questions? I'm open for questions. Thank you.
Yeah, Chris, can you hear me?
Yes, I can hear you.
Thank you for that wonderful presentation. I think I was trying to jot and follow you up, and it was quite an interesting one. You were very fast and very communicating and audible enough, just that the issue at hand about our network most of the time seems to be breaking and all that. But I think we're audible enough. We got about 95% of what you said. Thank you for that presentation. Also, I think we have a lot of issues when it comes to mineral testing. So it's not an issue of something that we are not aware of. When it comes to standardization of labs in Nigeria, it is something that has been there, and we've been clamoring for solutions and all that. Are you there?
Yes, I'm here.
Okay. So I think at least now we think that we have a lot of things are coming up. Even some labs the other day actually came up with some accreditation, which I was aware, and I visited the location. I saw it myself, and today we have some labs that are actually Canadian and association laboratories that actually accredited them. So I think we also need to increase more of those labs. And I think as a group, we need to do more in terms of, I was just waiting for you in the area of the group that actually standardizes lab in Nigeria. I wanted to hear their names and know if there are any form of standard or a group that actually control these things. Like you said, the Chinese can test whatever they want to test and give you the result they want to give to you. You like, you go to SGS. And before your product comes out, imagine when you've done about 4 weeks trying to load a truck of products, take it to Chinese that had their own lab in-house. They will test it, they will give you results. And at the end of the day, if you disagree, they will not agree for you to test it any other place in Nigeria. They will ask you to send it to China, or you send it to SGS, China, or any other place. Now, that is another 4 weeks or 5 weeks. So in most cases, they know that you need your money. You have no option than to say, okay, let's just agree on something, and you agree on something. But I've had the one they gave me, and my experience, I I disagreed with the results. I had to pay and went to test those things another location. Because it came up to be the same thing. So I accepted the results. Some not come out to be the same thing. So it depends on the integrity of some of them, because the issue of lab has a lot to do with integrity. If somebody testing, even a lot of things like what they're saying, there are a lot of things can happen, even human error can happen. Some issues can come up, no matter what you do. That's why more of the automated laboratories are more preferred now, because they can handle a lot of samples within some minutes. So I will, at this juncture, I will actually try to open the platform for some people that I want to make some contributions. If you are here, please, you can raise your hand. I will first of all take about 3 contributions before we go into questions. You have your questions, raise your hands too. So we had a lot to say, but I was just trying to rush you. So, so I believe that during contribution or questioning, a lot of people will come to understand what we are saying. There are some questions that are practical. Some people want to ask that some experiences they've got in the field or some issues they're having in the field, especially when it comes to artisanals and small-scale mining operators. Now, I think I will leave the platform open for contribution. So if you have any, please just raise your hand. I'll pick you up. I've not seen any hand yet. I might not. Or if you have it, you want to drop it on the bar, you can actually do that. Drop that on the bar, then I'll pick you. I can see Dr. Mrs. Salau. Maybe she just returned back from are you back in Nigeria? Are you still in Dakar? We are crying off network. I didn't know it was there. Can you hear us, madam? Are you sure she can hear us? Okay. I'm not sure. Okay, do we have anybody with okay, let me go to the bar. I have some.
Hello, Gideon, can you hear you? You are muted.
Okay, sorry. Can you hear me? From Dr.
Yes,
Adiola Adewale. He said, thank you for the informative presentation. I have a question regarding the use of atomic absorption spectrometry, AAS, for gold analysis. If AAS is employed for this purpose and the results are converted to grams per ton, can this result be used to make informed financial decisions regarding the value of gold in a given sample? I think there was a time we argued. There are the times something like this come up.
Yeah, so, right.
Okay, definitely, I know that gold is expressed in grams per ton. Anyway, you want to do that, and from what he's saying, if it expressed in grams per ton, can this used? And also, theoretically, ppm. If you say 7 ppm, it means 7 grams per ton. I think that was the question some other people asked. If you say 1 ppm, if you say 1 ppm, 1 ppm means 1 gram per ton. Theoretically, that's what it means. Now, the question is, if I have AAS analysis of 2 ppm gold, is that I'm talking to you, I have 4 ppm, I have 2 ppm. Are you saying that I cannot use this for financial decisions? What other kind of things do you want me to express it for me to understand that my 2 ppm or 3 ppm gram per ton means 2 gram per ton or 3 gram per ton? That could be used for financial decision making.
All right. Thank you very much for these questions. And, I actually had an issue recently with an international app, and let me not say. Now, you have to understand the difference between what gram per ton is. Now, ppm is telling you is a concentration unit, good and fine. Gram per ton is also a concentration unit. Now, after testing your sample using your AS, and then possibly your report was in, okay, you now got it in ppm. There is no way, maybe you got 2 ppm, just like you said. There is no way 2 ppm is 2 gram per ton. Now, what does gram per ton mean? Gram is a weight measurement. It's a measurement by weight. It's telling you that how many grams are present in 1 ton of the material. Now, the reason why the investor is not interested in your results in ppm rather than gram is in looking at the fact that, oh, if I have 20 tons of this material, and then I want to extract gold, what quantity of gold can I get from these 20 tons? And he can't be using it in kilogram because he knows that definitely he can't be working with kilogram because kilogram is a bigger unit. So he has to be in gram. So how many grams of gold can he get from this? Then after you have gotten how many grams, then you can now come to talk about what is the purity. That is when you can talk about your ppm or your percentage. What is the purity of the gold that has been extracted in this gram per ton? So you can't multiply because 1 ppm is equivalent to 1 gram per ton. That is a mathematical unit, not analytical unit. For you to do your gold assay in gram per ton, it means you have to do fire assay. And what is fire assay? You are extracting, you have a known concentration of your sample that contains the gold. You melt out the gold and then you weigh. It's simply a gravimetric method. And then you wait for you to know the weight of that gold that was extracted from that certain gram. And then you can now use that gram to calculate for a ton. So if that the weight of the sample you took for analysis was, let's say it was 2 grams, and then at the end of the day, you are recovering 0.5 gram of gold, you can now use this one to make economic decision. Okay, if 2 grams of this sample is giving me 0.5 gram of gold, how many of it am I going to have in 20 tons? So that is where you can now start making.
Okay, Chris, let me hold it. Okay, let me come up there. Let me make this very clear because you see, we are talking about concentration of gold here. And that is actually what he means. Whether it's in ppm, whether it's in gram per ton, it is still concentration. Now, if you are talking about methods, for example, I may now have faith in XRF of 4 ppm, but I might have faith because just of recently, I tested about 100 samples of gold.
Gram per ton, they want to know you can recover in every ton of the material. So if your XRF give you ppm of 2 ppm, that is not gram per ton. You can only get a gram per ton from your fire assay, where it's measured and then extracted either through precipitation, and then a final weight measurement is done. And then you can now use that final weight measurement to extrapolate how many grams of it you can get for every ton, not converting ppm to ton. The calculation unit is right, but that is a mathematical calculation. But when it comes to analytical, it doesn't work. Gideon, you are welcome back. You are still muted.
Okay, it said here, James Tito, Flixer, for a mineral buying center, what's the best analytical method for cassiterite, tin, columbite, and monoxide?
Okay. Thank you, Mr. James. Buying center, cassiterite in bracket. You now put tin and columbite and monoxide in bracket. Please, all of them are not cassiterite. It's only the tin that is cassiterite there. The columbite is on its own, and then the monoxide too. Sorry, the monoxide is not spelled correctly. Please, in case of next time, for purpose of learning, it's MONAZITE. So for cassiterite tin, AAS weight analysis like AAS is very good. Some people use traditional method of barating, but I'll still fall back to a more modern method. So AAS, if you have an AAS, a standard reference material for tin, you are good to go. If you have an XRF is fast, very robust, very, very fast. So if you have a standard reference material that you can calibrate your XRF, is very good for your tin. And then the same thing goes for your columbite too. If you have an XRF, you are good to go with your columbite. If you have your AAS, you are good to go with your AAS as long as you have a columbite lamp. Columbite is a columbite lamp, which is niobium. You have a niobium lamp, NB lamp, you are good to go. And then for monoxide, of course, monoxide, the best monoxide is in 2 ways. That is what we don't know. Is in 2 forms. One, you can determine the concentration of monoxide as monoxide grade. That's why you have, they say 80% monoxide, 90% monoxide, 100% monoxide. That is grade determination, and that is done through what we call gram scale. You take a certain quantity of the monazite, a known quantity, and then you use your magnet, and then you remove the other materials that can be attracted by magnet, and then the other one later you can now weigh, and then you get the final weight. So you can now use that one to calculate the grade of monazite. Then there's another unit, we call it TREO, total rare earth oxide. For TREO content, we are talking about the total content of the rare earth in oxide form. You can use your XRF to do that. Take, for instance, now for monazite, you're having elements like plasmodium, PR, lanthanum, La, and so on, and cerium as the highest constituent. You can use your XRF as elemental, and then you convert that element to oxide, and then you can now sum up the total rare earth oxide to know your TREO. But there's another one again, they call it REO. REO, R-E-O, rare earth oxide. REO is a specific, a specific quality of the entire material. So it's not an individual, it's not an individual unit, the entirety of the whole material. So for you can only use ICP-MS or I
really ask a question about that consignment that went to China. That consignment that went to China that turns out not to have the target mineral in China. That kind of situational wealth to be wasted. Is there any way to, is there, I mean, what type of contract was even indicated in that consignment, Jerry, that he can go to China and then return negative testing? That's one. Okay. Two, what will you suggest would be the right way to determine quality of material right there in situ at site prior to export? What will be the right method to, will it be non-destructive analysis, or will it be chemical analysis that clearly states clearly what is on that consignment prior to lift up from site? Thank you. If you can address this issue for me.
All right. Thank you very much, Sir Patrick. Glad to see you. Right. Regarding the consignment, that is why you need to always have a third opinion or a second opinion, as the case may be. If you have a material that you want to chip out of the country, you can't just rely on one lab analysis. There might be mix up somewhere. Maybe I was even trying to extrapolate this. I was now noticing there is no way 10 containers will come out zero. So there's a possibility that there was a mix up in the lab where other samples was now mixed up for this other man. Now the result came out that the result is positive, whereas it was negative. So there is no way you should use one result when it comes to export. For exploration, you can do whatever you want to export. You're already putting economic value on that material. Please send it to another lab again for a second opinion. And then so they can have an average. No two labs can give you exactly the same result. If lab A gives you 0.5, another lab can give you 0.6. So you can know the range of grade between the two labs. So you can use that one to make your economic decision. So the fault was from them. And then secondly, that is why we need to have a regulatory framework, or the labs has to have a regulatory framework. Now, if you go to sue this lab, you can't take this lab to court because number one, Nigeria does not recognize that that lab is a practicing lab. So it means you went for a background, you went for a backyard business. So, but for you to be able to sue that lab, you have to go to a body that lab has registered, whether NINAS or IPAN, and then report this matter to IPAN. Is the body that now take up the matter. First of all, they will suspend their license and then investigate why there was such disparity. But if you want to go and drag them, not so that you your something else opinion. Thank you. Then in terms because your SRF is SRF it has a lot of matrix effects that can actually attenuate and cause attenuation of your signals and might be giving you wrong result. So take your sample to a lab that you are confident with. Let them. Once you come back with your result, you can now send back you can now decide to chip the sample or not. Don't make a haste decision by saying, let me just use a non-destructive or institute testing, test my material. It's not in a hurry, except maybe the money is free money. But if you actually spend money in getting that material, please take the sample to the lab. Don't rush it. Get a proper analysis done. Possibly also get a second opinion from another lab before you can export your sample. Thank you.
Okay, let's hear from Aziz was raising his hand before. Aziz, are you still there? James, are you there? James, are you there? Can you lower your hands and unmute yourself? Okay, Aziz, can you make you were raising your hands before? Can you unmute yourself? Aziz Mohammed, Abdulaziz Mohammed, if I'm correct. Abdulaziz Mohammed, can you hear me?
Okay, please go ahead, Mr.
Okay, I think I can't.
All right. Yeah, thank you once again. Yeah, hello.
Okay, Patrick, I think we can hear you.
Thank you once again. There was an analysis that was carried out at the lab, and the lab has recently come out and said that it was not for material to get our and arguing, and they continue to argue from their own side that the oxide might be above 100%. Maybe I can share this analysis result privately with you, Christopher, so you can have a look at it. But I have my doubts that I've never seen any analysis. I compared it with Alfred Knight. I compared it with MS Analytical in Canada, and none of their results has been above 100% when you calculate all the elemental counts. So is it possible at all for have a sample that can go above 100%?
Okay, Chris.
Okay, thank you very much.
That is the usual.
Yeah.
Can you answer, please?
Yes.
We are running. We just have 5 minutes to round up. 5 minutes to round up everything.
Okay.
Yeah.
Of course, it's possible. I'm going to give you the reasons. Maybe later I want to share the results too, possibly. Now, it depends on the way the results were presented. Were they a mixture of oxide and elements in the table, or was it just elemental, or was it oxide only?
It was mixed. It was mixed. It was both oxide and elemental. But
of course, it can be 100%, because elemental, when you're talking about elemental composition, is different from oxide. Oxides are a compound. So if you want to know the balance, it should be addition of all the elements should give you 100. Then if you want to know the balance for the oxide, it should be the addition of all the oxide that should give you 100. But if you're adding both the oxide and the element together, definitely you're going to have over 100%. So it depends on how the result was presented.
I actually calculated the oxide separate, because once I see the O, I know it's oxide, and then the elemental separate, and it was above 100%. And
Patrick, I'll think
the best thing, aspect.
Yeah, the best thing would be to send the sample so that he can look at it technically and possibly see where the issues are coming from. I think that would be the best way to go.
Sure.
Okay. Thank you. Thank you for the question and your contribution. And Christopher, we cannot thank you enough today for that. Also, I think in short, somebody says they are illuminating a presentation. A lot of accolades here from the platform. based on performance. I think we still have our AI chats going on. In case, even if after this presentation you want to chat, you want to send us anything at all, questions, you can actually do that. At the end of this presentation, we will send your slides. We'll send a slide to the platform. If you've not joined, if you want the slide, if you are not part of our group, you can send your email on the bar, then it can actually send to you. Then the video also, when it's ready, the link will always be sent to the platform as usual. I think we're going to be drawing cutting for today's presentation. We're going to be looking at the next one will be in November. I think that's not going to clash with the mining week. The mining week, I think, ends by 21st. We'll have last Wednesday. Yes, last week.
There's an important question here that I just saw. And
okay, where is it?
A very
just now?
Question.
Just now?
Comfort.
Where is it?
I think he has been there.
Okay, no, I didn't see it. Okay, that's another challenge regarding the China case is sampling procedure adopted by the miner. Can Mr. Chris throw more light on sampling? Okay, on sampling procedure. Okay, on more light on sampling. Okay, can you use 30 seconds to do that? And you? Hello? Chris, it seems we've lost him. Okay.
That of interest. There's going to be any deviation, it should not be more than 0.2 because any part of the material you are taking, they're definitely going to have the similarity to each other because you have crushed it, you have uniformed it to a certain degree. So certainly your sampling protocol will be very effective. But if the material is not uniformly distributed and they just want to sample, there are different lump sizes. There will be some lump sizes that are 5, that are 6 millimeters, 7 millimeters, and there are some that are 3 and 4. So depending on how you take your sample, you definitely end up having disparity in results. So for you to actually address this issue, ensure that your sample, your particle size, your particle distribution is uniform. Either you keep it at a standard 4 millimeters or a standard 5 millimeters. Just ensure that it's uniform so that wherever you take your sample from, you should do a representative sample that will tell you the average grade of the material. Sampling for alluvia is very easy. For things like tin monazite, they are very easy because of the particle size. So that one, efficient mixing should be done. I think there's another time we're going to be talking on, there's another webinar, we're going to be talking only on sampling so that we can actually understand the importance of, withdrawing an average sample to give us an average grade. Thank you.
Okay, Chris, thank you. Lastly,
thank you very much.
Thank you. Doctor, you are still there? Dr. Comfort?
No, I was just thanking him. There's no time. I would have also made some contributions, but maybe next time.
Okay. I wouldn't mind giving you 20 seconds because you are very rare. And I think this one I've caught you. You can give us the contribution in 20 seconds. No problem.
All right, thanks very much. Mr. Chris, maybe next time also you can consider that all our miners, instead of shipping out the ores in that form that you get to China and the game changes, why don't you consider having pulverized form, uniform pulverized material being shipped? It is too costly for you to ship in 10 trailer, 10, whatever container, even if it's 1, and then it returns that it is all 0. I completely disagree because every material has got with it a lot of resources. Apart from that lithium, there's a lot of resources that is in it that the Chinese man or the other businessman at the other side may want to take advantage of. So if IAMESEP can have a pulverization station that everybody comes there, you put together some funds, pulverize, and then have a package that is going to China, there is no way that the game will change halfway because you have a uniform material. Thank you very much, all of you. Dr. Neye, hello to you.
Thank you very much, Dr. Comfort.
Okay, thank you, Dr. Comfort. Now, there's something she said. Chris, there's something she said I had issues with most of the time, especially I've thought of it. When I was in the field, I wanted to do something pulverizing and all that. I found out that there's something I wanted to ask. How do you ensure that the previous sample you pulverize are not within the system where you provide a new one, how do you ensure that there's no contamination from the previous samples or sample 1, sample 2, another? How do you ensure that? What is the real procedure to clean up?
Sure, there's a standard.
Yeah.
Of course, there's a standard procedure.
Not to do something. Yes,
so
I understand.
The
So how do you do that?
on
If someone has a smaller pulverizing machine, how do you? Is it possible to get a clean sample, each one to be without contamination from the previous one?
Yeah, very well. It's very possible. So basically, there are two ways. I will tell you, one way is expensive. One way you have to have, there's a sample, we call it a blank sample. It's quartz. We call it blank sample, quartz. So after crushing your main sample, you remove your main sample, you put in quartz, and then you crush it. That will definitely wipe off every other contamination that might be present. Then another second method is for you to get a hair compressor. Remember, you are pulverizing to powder. So definitely what will be left in your system is powder. So you use your compressor, a compressor, you spray it on your pulverizer, then you use a clean towel or whatever, and then you clean up your system. So definitely you're not going to have a contamination.
Okay, thank you very much. And thank you everyone that have actually participated here today. So for that question, please, you can actually send to our platform, and we'll thank you once again. Let's see some people that are here. I want to thank you, Dr. Comfort, for coming. Esther here. Dayola always here, but you will not contribute. You know, I always call your name. And Dr. Jude, interesting, you are here. Nobody heard you today. That's not, I hope you are somewhere. Okay, and Dr. Misala will thank you for coming. I will thank every one of us that have made this an interesting thing today. Prince Ijoma, thank you. Patrick, thanks always for your contribution. And one of us also is here. Victoria will thank you for actually coming. Sam, Uzumba, and the rest of us that are here. Please, I want to thank everyone, and let's have another date next month, last Wednesday of every month. So we thank you all for participating. Have a good day, and legs are ahead of you.